I hate you both.
He made it worse. I didn't say
Yeah, well, it's basically just as bad.
You don't get to decide that.
Well,
You don't get to
I
decide.
have.
Oh my gosh. Why does it keep on going here?
We have to download a package.
Yeah. Shit. I need to do that. It's the same one from last year, so it should be fine.
It's a different like ERP or URP, or just like a regular
It's URP. I'll probably get started at like 6:15. Man, doesn't the later half of the spring semester always feel like school's already over?
Yeah.
Sucks.
No, I put this on for you.
What?
Jake said it's something like
Oh. Well, there's the good thing, or there's like, yeah, I'm happy that school's almost over. Also. Fresh time.
Scary. What are the graduation things that you need to do?
Did I could apply, get it approved,
Mm.
and then still need to buy the cap and gown and stuff.
Mm. Yeah.
Extremely overpriced.
But wait, does it have to be theirs?
I think it kind of has to.
Really? That's so dumb.
you going to high school graduation.
Like it has to be their cap and gown.
That should at least be black.
Honestly, there's probably places you can like
Wait, is that
buy hand-me-downs.
they're
You
black?
still need to buy the skull.
And that's theirs specifically.
Well, unless you want to like walk into graduation with like University of Iowa computer natural science. Or something.
Look, honestly, I would do it. Who cares?
Can I
I mean,
quote you on
it's for
that?
you, so
I mean, honestly, do you need it? It's only if you like want to attend graduation, right?
if you're not walking, you don't need it.
I'm just gonna skip it. I don't give a fuck.
Your parents don't care.
My parents probably care.
I'm literally only doing it for my parents. So it's good.
I guess that's a good point.
'Cause I kinda like my parents.
I'll try to talk them out of it.
That's how.
My sister never had a graduation because of COVID.
You have a sister.
Yep. Never had a graduation, which kind of sucked. But now that they're doing like a redo of it later on, she's also considering if she wants to go or not. Because honestly, I think it's a waste of time. And she kind
Supposed to be like a
she kind of
celebration, you know,
yeah.
but
I guess like 3 years afterwards isn't as significant.
yeah.
Yeah.
How long has it been like that? Or not like that? 2 years?
Sometimes been
Yeah.
COVID-19, but it was the tail end of 2019.
They canceled the
So,
graduation because of COVID,
yeah.
or like it was going to be online.
So once it's like December of this year, then it'll be.
Oh my god.
Let's go.
Oh my god. That's the age of a small child.
Oh, no.
COVID's taking its first steps.
Where
Oh my god. We'll start in like 5 minutes. Oh, I wonder if anybody's actually in the room. I have not been checking. Nope.
Sent out a bit late.
Yeah, that's true. Oh wait, yeah, is it actually okay? It's up.
Oh,
It's up. Hmm. This will be a very chill workshop if you're the only one here. It'll be cool. I'm just gonna be mentoring you directly. Honestly, it's fine. I'm actually kind of thinking like more people than I thought watch the videos for the workshops.
oh really?
Yeah.
Check. Oh shoot! I'm gonna send that.
Yeah, you need to tell them. Which one was it for the?
That's like the
Was it the texture painting one?
yeah the animation.
3 minutes to go before I inject knowledge into your brain. Have you taken graphics?
No.
Oh, okay. This would be interested. You should take graphics.
That's one of the classes I really want. Is it only in the spring? That's the one I hear.
Maybe. I think so. Oh my god. You're right. You're right. Pet the doggy. Pet the doggy.
I saw him play it.
Oh. Hades is so good. Hades is a time sink. Just by the way. I'm gonna edit it.
Oh, you're gonna edit it, definitely.
Might as well. Should be 31st. Okay. Also, why is it 7 to 8? It should be 7 to 9.
Yes.
Did that fix it? Okay, cool. Yeah, it's fixed. Man, yeah, this is not a good week for us. I guess it's fine. First week back. And besides, this video is gonna be good. Gonna make it good. 1 minute to go. before you get educated.
Oh no. My first night.
Oh yeah, Dio, you already opened up the Unreal or Universal?
no.
Yeah, no. Universal render pipeline.
Yeah.
Cool. I'm gonna make mine too.
Recorded.
Workshop. Great. Oh yeah, I forgot to mention, but the editor version, it doesn't matter too much because it can work in either one. But I'm gonna be using 2020, which has slightly different UI.
Oh, I mean,
Yeah.
Okay, cool. Yeah, we found out that last year with Robin. You're just like couldn't do it because or like
It was just confusing.
There-
I mean, it's like after looking at it a little bit.
there was just
more,
a drop down menu,
They're just
but
they're
they
just,
didn't know it was
slightly
there.
Yeah. Like the 2020 version, they hide some like extraneous info. Well, quote unquote extraneous. We needed that.
we use that. Okay, so as my Unity project's opening, I'm gonna share you some info. Also, wait. Yes. You've already downloaded the package? Yes. Okay, nice. Hades. This is what it looks like. Very nice looking. And you could have done this by just making very complex animations for every single one of those objects. But why the hell would you? That would really suck. Like, look how many frames that has. All of these are made using shaders. That lava over there, it especially looks like hand-drawn animation, but it is using shaders. And that's because shaders are very useful. You're gonna want to be able to at least tell what can be made with a shader, even if you're not doing it by yourself. Okay, so let's do a rundown of what shaders are kind of made up of, and that kind of starts a bigger discussion on what 3D graphics are made out of. And it starts with three core things: a mesh that describes a 3D model with vertices and faces and normals, and these meshes usually don't actually have any detail on them. It's just the structure of your model. And the actual graphics come in when you add a material onto your mesh. And a material is sort of like it's sort of like a descriptor of the graphics on a mesh, because it can have, this right here is a texture, is like 2D image. Materials can have textures, but materials can also describe different amounts of metallicness. It can describe how smooth the texture looks on it. It can describe a base color that tints the texture. So materials are also kind of like, it's kind of like a struct, just holding information for your 3D graphics. And the last thing is a shader. And materials can be made out of shaders. You can make, like a material can be a child of a shader and implement the functionality of that shader. And what this kind of means is that shaders use the information in that material to create visual effects. So you can kind of see this is a water shader, and it uses this texture. And something it'd be able to do if you made a material out of the shader is you take different textures that you put into that shader, and you can take values from the material, and then you can make your material look like this. The shader is like the logic behind the material. Yes, Digo.
So mesh is just like the verse.
Just the vertices.
And then a material like contains also the texture.
Yeah, so a texture, the definition of a texture is a 2D image.
Okay.
It's a sprite. And you can put a texture onto a material, and and then that material would map that texture onto a mesh. Because if you think about it, right, textures being 2D images, it wouldn't map exactly correctly to any single mesh, and that's what the material is kind of like taking in that texture, determining values that are called UVs that kind of map that texture to the mesh. Yeah. Okay. Hopefully, I don't expect you to understand it, but hopefully that's easy to visualize. Material is kind of the middleman between raw assets and the visual aspect of meshes. Okay, let's move on. So I also want to show you some like actual tangible things of where Unity does these. First off, the mesh. If you look at the default mesh filter of a game object, you might notice this on any 3D object that you make. You will take in a mesh, and that tells that game object which vertices to have when you're in the editor. And then when you're rendering that mesh, you can use materials. This is what I'm saying, right? Like, it's kind of a middleman. And then that material itself can inherit from a shader. And this is a shader that I made. And this shader can, you can have like public variables on shaders that you can customize. You can make new functionality for that shader. And that's something we'll get into more when we're doing stuff. So today's plan, I'm not sure if we'll actually have time, but today's plan is to make a cutout shader and then go onto a EGaDS lava shader. The cutout is more so we can cover the basics, and EGaDS is really to show what the potential of shaders is. Diego, yes.
A little unrelated, but somebody in the Discord asked me if alumni can join.
Oh, yeah. Why is it always here?
And they said they're nice, but I think they meant for
Jake, can you respond to him? Nah, that's very helpful.
So yeah, the room open or
Room's open. Zoom room's open. It's recording. Okay. I'm wondering if I should. I'll just go on. Okay, so we did that. So I want to show off what specifically made me want to do a EGaDS shader workshop, and it's this video. Maybe I'll wait until the guy gets in.
Yeah.
Or maybe I'll just play it a couple times because there's a lot to deconstruct here. Right, so they're talking about how they did a sword effect. So they add those effects together, and already it's like, whoa, that's so complex, right? It looks like such a complex effect, but it came from very simple individual elements. So the first one they did was a sword screen. Now they're doing a projectile. And this is the one that we're making. Start out with just fractal noise, another layer, they add them together. They do some other stuff. I'm not going to claim to know everything that they do, but I got a close approximation. from that, you must be like, what? How'd that happen? Well, I'm gonna be showing you in some steps. Okay. Huh. Is the guy gonna join?
No, wait, yeah. I replied to them.
Yeah, right?
I used the reply at thingy too.
Yeah. Oh,
Uh,
okay, but we're gonna go on just to keep pacing. If he joins, I'll show it again. Why not?
yeah.
Okay, so let's actually move into our Unity project and start putting together our first shader. Whoa, okay. All right. What's this here? Yeah, that shouldn't be there. I'm gonna arrange my workspace a little bit. It's nice to have more room for this. Okay, so the first thing that we're gonna do is right click, go to create, shader, and then universal render pipeline. And from there, we're gonna click on lit shader graph, and we're gonna call it cutout. We'll double click on this, and it's gonna open a window for shader graph. And I'm actually gonna pull it out and just like make it an individual window just so we have more space and maximize it. Yeah, cool. Okay, so you're gonna see that we have a couple of different, but right now we only have 2 nodes, right? And there's a vertex node and a fragment node. And this is our output. These are our output nodes. Whatever we're gonna be doing, we're gonna be putting into these, and it's going to reflect in the overall shader. So let me cover the controls really quick. Left click is select, right click brings up a menu, and when you press down middle click, you can pan. That's going to be your most important one, mostly. Pressing down middle click. So you can also scroll in and out. And another important shortcut is if you press space, you can create a node. The first node we're going to add is an ellipse. Wow, ellipse, cool. And let's just plug that into base color for now and see what happens. So you can see the preview down here. Plug that in. It's loading. Wow, amazing. Has a circle on it now. Yeah, so, if I did more stuff to this ellipse, those changes would be reflected down here. And you can also right click on this and put in different meshes if you want. Capsule. Okay. So those are the pure basics of shader graph. Let's go into our graph settings up here and start making our actual cutout shader. One second. I need to check something. Okay. So first thing that we're going to do in our graph settings, we're going to make our surface transparent. And that basically allows us to have partial alpha values. We can actually drag our ellipse into alpha now. Wait. And you can see it actually made part of the circle, everything outside of the circle, transparent. So the quad was a square before, and now it's just a circle because everything else is transparent. Cool. Capsule. Yeah. Okay, and this is a good time to actually explain something about shader graph. Most of the time in shader graph, you'll see values between 0 and 1. So specifically for alpha, it can be between 0 and 1. And the way that it's visualized in shader graph is black to white. White is 1, black is 0. And that allows us to do a lot of different things. Maybe like if you take a vector 3, you can use the x value to plug into the alpha value or something, and it becomes a 0 to 1 value. Okay, let's get started with more of the stuff, with more of the actual stuff. I mean, oh, 1 second. Oops. I'm just going to bring up my reference. Okay. So the first thing that we're going to do is add some variables. First thing that we're going to do is a texture 2, and we're going to call it the main texture. We're also going to add 2 vector 2s, one called tiling and one called offset. Oh, real quick before I forget, this tutorial is based on this workshop is based on this video. It was a very good video, very easy to understand, very good shader. I expanded upon it a little bit, but ultimately check this guy out. Is a very useful video. I'm doing it more so that I can explain some of the basics before we go on to something more complicated. Okay. Main texture, tiling, offset. We'll also do a vector 2 player position. And we'll do a float cutout size. Okay. When you click on each of these individual properties, you can see some of the stuff here. You can set defaults. For this one, let's just put something random. Let's put the help icon. Why not? It'll help us like visualize if things are working. Click on tiling. We want this default to be 1, 1, 1, 1. Offset is fine as it is. Player position is fine as it is. Cutout size, we'll do a default of 0.5. Okay, now let's use some of these. Let's move this down. Okay, so let's press space, screen position. And what this node does is it finds the screen position of anything. It finds the screen position of the object the shader is on. So the screen position is when you look at your screen, literally where it is on your screen. That's why it's an XY. Okay. Oh, you know what? I think, okay. So this preview thing is actually showing you what the value would be on an XY grid. Imagine this box is an XY grid. It's black down here because that's 0, 0. And yellow is 1, 1. So imagine your screen like that, and that's what the vector is. Okay, so we're gonna drag this out. And when you drag out a node, it automatically asks you to create another node that it will attach itself to. let's put it on tiling and offset, UV. So we'll go here. And we'll also, I'm gonna rearrange this. We'll also fill in the tiling and offset values. Something we're gonna do for the tiling, oh, whoops, is just drag over the property from here into our scene and connect it. And for our offset, oh, wait a minute. Okay, wait, sorry. I forgot we don't need offset. Delete that. We're gonna be using player position instead. Because what an offset would just give a constant value, but we want the cutout to be at the player position instead. So we'll drag in the player position. We'll drag it into a node called remap. And this is because the screen coordinates are kind of weird, so we need to make the numbers different. Remap, you know, based on the name, it sort of remaps the numbers into different, into new ranges. And then we'll do an add into B. And then we'll add screen position to that add. I'm going to collapse these. And I know this is kind of tedious, but it'll be cool. Okay, and then we take that add output and we put it into the offset. Okay, and then finally, we take that tiling and offset node and we drag the output into base color. Save asset. Okay, and let's check out our main preview. Cool. So what's our main texture? Should be this. Oh wait, no, sorry, I'm done. I'm done. We take our main texture and we drag that into a sample texture. It samples that help button. We drag our tiling and offset into our UV, and then we drag it into our base color. That is my bad. So now you can see it's blue, which is the help button texture. Let's actually get rid of this node for now, so we can see the entire thing. All right, we've got a blue cylinder. You can actually kind of see it in this preview, but the eye is in the corner. And that's because the default value for our player position is 0, 0, right? Which would result in it being lower left corner. We can actually change our default value to 0.05 or 0.5, and then it'll be center. It'll bring it to the center. That's also an important note. The preview works off of your default values. Okay, so now there's an interesting effect, right? If you move around your cylinder, the eye stays exactly in the middle of the screen. Oh wait. Did I mess up? Oh, I messed up. Oof. Okay. Yeah, I messed that up. This part's actually used somewhere else. So I'm gonna delete this connection and instead make a new tiling offset node. Put our tiling in there. And drag that into our sample texture instead. Okay, yeah, I was a little confused. Because this is the effect that we want on our cutoff, right? To stay exactly on the player no matter where we're going. Okay, cool. So now we have this eye on top of our capsule. And it's mapped, normally. We can kind of see what tiling does if we increase this value. It makes the eye thinner. Almost like you're tiling it more times. Ooh. If you want it to actually repeat, you'll have to find the main texture. You'll have to find the texture itself. It's over here. And set it to repeat for its wrap mode. And then inside of your shader, it'll actually loop. Where's my shader? I can't. Oh my God. I can't grab my shader. This is so annoying. What's happening? It was hiding behind the taskbar. Save asset. And if the tiling goes up, it repeats. Now you got multiple eyes. Wow. Okay. So let's go on to the cutout part again. We have our tiling and offset for it. We want it to be exactly on player position and not be dependent on world space. It only stays in the middle of the screen, depending on where the player is. After that, we'll drag it into an ellipse. And then we'll put that ellipse into the alpha. And this takes a while. So you'll kind of see, right? That eye texture, we're sort of like subsecting a circle of it with the alpha. Even if we're rotating the cylinder, we're only taking a section of it. And you might be looking at this. This is actually like what we want for our cutout, except inverted. So we'll take this ellipse and we'll do -1, 1 minus.
Is the room open for, sorry,
It should be somebody.
open for non-UT students?
I don't know if that's a setting I can check or not.
So, click on security. The Zoom link.
Where? Oh, here.
Yeah. And then I swear there was one. Try more.
Meeting info. Security
Okay,
settings.
yeah.
Oh, I can't change these.
Oh, you can't change those.
Wait, check this.
Maybe you can change it through there.
No, that's not it. I don't think we can change it right now.
Yeah, I think it just has to be through the
Ah, man.
meeting.
Dang.
I'll just have to. Oh, they asked if there's recording.
Yeah, there'll be a recording. Okay. So we drag this into 1 minus, and then we drag the 1 minus into alpha. And then we'll see. We'll see that we have a cutout in the cylinder. That is what we would want on our cutout for our cutout shader. Yes, Digo.
Can I see your rematch node for the?
Yes.
Why is it 7%? Oh, I had it.
Yeah. Okay. Cool. All right. So now that we have this, let's actually try to put it on an object inside the scene. Yes, Digo. No
I
worries.
was wondering, like, I see if my line is correct here.
Yes.
What is happening here?
Okay.
So, like, the bottom half of the nodes, that's deciding like the position of where the cutout should be.
Yes.
Defining the cutout to be an ellipse,
Yes.
and inverting that like texture so that we have a circle at that location,
Yes.
or ellipse at the location that should be cut out. Right?
Yes.
And then what are the top couple of nodes here?
This top couple of nodes is doing like default texturing and tiling and offset things. Default texture offset tile. You can do that by selecting some nodes and then pressing Control G. Yeah. And then it groups them. Yeah, so like, you know, we're doing shader logic down here, but we still want to give the user options to put on a texture if they want to, tile it if they want to, give it an offset if they want to. Yeah. Okay. Let's put this on an object. Ask me again if you need to see it, but let's just make a wall, game object, 3D object, cube. How far away is this cube? 0, 0, 0. Bring it forward. We'll scale it up in the Z, 15, 15. This is a wall now. And we're gonna put on a material onto it. Well, we don't have a material, we only have a shader. We'll right click the cutout. We'll create, and then we'll create a material right here. And then we'll make the cutout map. Okay, cool. So this material is made from this cutout shader. And now we can drag this material onto this object. All right, cool. And now we have a shader. So this allows you to like preview it. Pretty cool. But immediately we'll see that there are a couple problems. The circle is not completely round, and it's just staying in the middle of the screen. And that's because we set the player position to 0.5.5. That's just the default. And the cutout is gonna stay in the middle of the screen, right? We don't want that. We want the logic to specifically keep the circle on a different object. So let's keep working on this. The first fix that we're going to do is we're going to make this circle round. And the reason why this is happening is because we're putting a circle on screen space, and it does say that this circle is symmetrical, but screens or aspect ratio is not symmetrical. So this circle asymmetrical when going onto screen space, and then it gets stretched out because the screen space is wider than it is tall. So what we need to do is actually take account of aspect ratio. So what we're going to do is do camera. We're going to take in the width into a divide node and take height into it too. That's our aspect ratio. And multiply it. And we're multiplying it by our cutout size. Where are my variables? There they are. We're going to put in cutout size. So cutout size goes into the multiply, and it also goes into an X. And then this multiply is going to go into the other one. So if that makes sense, let me explain that a little bit. You got the aspect ratio, and then you multiplied it to cutout size. But then you defined an ellipse with cutout size at width and your multiplication in the other one. And what you pretty much did was you put in a ratio of the aspect ratio and the cutout size. So now if we look in our scene, and remember I might have done it in the wrong dimensions. Now it's even wider than before. But yeah, if you want it to update in your scene, you also need to save the asset. So I think I did it in the wrong ones. This one would go to height then. Then this one would go to width. Save your asset. And boom, perfectly round circle. Round circle. Okay, so now that we have that, let's add some of the logic behind this. So we're going to be using a script to attach onto the shader. If you want to use a script on a shader, you usually are doing it so that you can alter some variable. In our case, it's we're wanting to change this player position. And when you're trying to do that, you want to change the reference name of this variable so that it's easier to get inside your scripts. Naming convention is starting with an underscore and doing player pause. Oh, actually, before I do any more, I know that shaders are kind of brain hurty. I'm gonna take a break and start back up at 7. Any questions? All right, I'm gonna give this a break and start back up at 7. All right, it's 7. And now that it's 7, you know what that means. Jake over here disrupting the workshop. Okay, so we have the circle, and we're about to what's the word for it? Implement code logic into it. Yeah. Okay. So we're going to go back to our project window down here, right click, create a script, C# script, and we'll call it the cutout sync. Whoops. That's going to cause problems if I don't fix that. I think I just need to restart. That was dumb. Yeah, my laptop really can't handle this much 3D universal render pipeline stuff, but it's going through it. So we're going to open that script, double click, open up whatever IDE you use. It's taking a while. Okay. And we're just going to be adding a little bit of code to make our shader accurately work. We're going to be putting this on, we're going to be deleting our start function. Or actually, sorry. No, we're going to leave it. Might as well. And we're going to add a variable, public static int. And we're going to call it position ID, pos ID. We're going to do shader dot property to ID. And we're going to pass in that name we gave it. So it was player pause. Yeah, player pause. Okay. So now we can access okay. And now we can access this property on the shader. We're also going to add a public material. Call it wall material. We're also going to do a public camera. And a public layer mask. Okay. So what we're going to be doing with these variables is we're going to be raycasting from the camera to the player. And we're going to see if there's a wall in between them. And if there is, we're going to make it so that oh wait. Let me do this in a different step first. So just for now, let's have it so that in update, our wall material just always sets its float of the position ID to something called view. And we're going to define view as camera.world to viewport point. And we're going to put it in the transform.position. Oh, whoops, set vector. Okay, cool. So now that we have that code in, let's go into our Unity. And we're going to be putting that on our player. So let's just drop in a player right now. I'm just gonna put in a capsule. Why? Be in the center. Okay, we've got our player. We're gonna smack that script on him. Cutout sync. And we're gonna put in our cutout material into here and drag in our camera component from the scene into here. We're not gonna worry about the mask for now. Okay, so now we're gonna press play. And we're gonna go behind the wall. And you'll see now the circle actually stays on the player. Nice. Nice. That's a cutout shader in its most simple form. But to be honest, this cutout shader is not very good because, for example, yeah, we don't really want this. We don't really want the cutout to be active when you're when you're just facing the player and there's no wall in between you. Right, this is a problem. So that's why we're gonna raycast. We're gonna raycast from the player to the camera. And if there's anything interrupting it, then we'll make the shader active. So the way we're gonna do that is we actually need to add another field to our cutout shader. So we're going to add a float, and this is going to be called wall flag. Its default value is going to be 1. And we're going to multiply it with the ellipse. Let me actually check if that's right. Yes. Wait, maybe? Okay, yes. So we're going to multiply it together. And the basic logic behind this is if our wall flag is set to true, then it's going to make, then it's not going to do anything, right? Because it's multiplying by 1. That doesn't do anything. But if our wall flag is set to false, which is 0, it's going to multiply this circle by 0, which effectively makes every single pixel in this node black, which makes it every single pixel into 0. And when 1 minus, it just doesn't do anything, right? So so it makes it so that this shader doesn't do anything and the cutout is not active. So let's save that. Or okay, we also need to set the wall flag reference name. Let's call it wall flag. Save asset. And we're going to go back into code. So now that we have that wall flag value, we can get that. I duplicated that line by saying Control D, and we're going to do wall flag. Okay, cool. And once we have that, we're going to go into update, and we're going to raycast now. We're going to do the var dir equals camera dot transform dot position minus transform dot position. That's getting the direction from the player to the camera. We're going to define a ray to raycast with. this is a transform dot position and dir dot normalized. So what this takes in is an origin point and a direction to make a ray. And then we're going to do a if physics dot raycast. Give it the ray that we defined. Then we need to do a distance for that ray to go. We'll say 3000. And then we're going to give it a mask. And that mask determines what it can collide with. We don't necessarily want our shader to only be active, we don't want our shader to be active when anything's in between it. We only want it to be active when there's a wall in between it. So that's why we make a mask. Once we have that, we'll do the wall material dot set float. We'll get our wall flag ID and we'll set it to when we're colliding it to something, we want to set it to 1 so that it's active. Else, we do the same thing, but set it to 0. Okay, I'll leave this up for a second. And hopefully this should make it so that our shader is only active if there is a wall in between it. And this won't work in scene, right? Because the scene, oh, oops. What did I do? Did I do this? Oh man, I don't know what I did there, but whatever. We'll press play. And now we'll check. It still works. Or it still doesn't work. Dang it. Oh, it's because I didn't make a layer mask. Right. Hey, Jake.
No.
Do you know what happened here? I locked it to an axis and I don't know how to redo it. Undo it. Oh, wait. Okay, cool. I'm just dumb. Okay, so we need to make a layer mask now. So I'm going to click on this capsule that we made. I'm going to add a layer and I'm going to call that layer wall. So now that a wall is created, we can put it on our wall. So click on our wall, set its layer to wall. And then in our capsule, we go to that script and we have this mask only target walls. So now in play mode, for the second time, why? What? Dang it. Oh, really? Weird. That's funny. Weird. Let me think about this. Cutout main material. This wall flag should be 1 on default. Go to 0. I set it to 0 here. It's really weird that yours is working and mine isn't. Yeah, sure. It's just so weird. Why isn't it working? Wait, I'll just come over to you.
Oh, you can kind of see the corner.
Oh, yeah,
Player.
that's how it should
Yeah,
work.
that's fine. I don't know if that
Hmm.
looks different in yours. What's the same?
Hmm. Yeah, go up.
Oh, doesn't it have to have an
Oh, that's why. Okay. Mystery solved.
Are
Thank
property
you.
IDs like they're just global variables?
Property IDs are practically just global variables.
Oh,
Yeah. They're specifically like for customization. But yeah, they're also like public and you can access them through script. Okay, so now as you can see, it works thanks to Digo. Nice. So now it should only, okay, and this is an important distinction. It doesn't work on this wall, and that's for two reasons. We didn't actually make these materials out of the shader. So they don't have the logic for a cutout at all. And it's also because they're not on the wall layer, so they wouldn't have been able to been activated in the first place. And now if we see here, this wall does have that shader and that logic and that layer, and it can be a cutout. Nice. Woo. Cutout shader. If you want to make it look a little bit better, there are some options. You can like add dithering. I'll show that off like really, really fast. You can put this circle into another node called dither. Oh, wait, I need to do it at a different place. I need to do it here after the multiply. You put it in dither, put that back in. And alpha. Save asset. It's loading. And in play mode. You can kind of see that effect a little bit. It's like dithered, kind of more artistic. And you can also do that with like more intensity if you wanted to. The actual tutorial that I based this off of goes into more detail. They show you a way how you can like feather the edges so it's not a hard circle, rather it's a like blurry circle, and that looks like more gradual. This dithering is from a different tutorial. They also show you how to add noise to the outside edge of your circle, so it's not a perfect circle. It's a really good tutorial. You should check it out. Okay, so now that we've done this cutout shader, let's move on to this next shader, the lava shader. And I'll be trying to just like hit the key points. This is more just to like show off how powerful shaders can be. Okay, so I need to actually download that package. Forgot to download it. Make sure you have this. Make sure you have the package from the announcement downloaded. It's in the channel EGaDS events. And once you have it, drag it in to import. Import all. And it will add a folder called My Shaders. So go into that. So I put in a bunch of different assets already, some images, some masks, and one 3D model. and we're gonna create our shader in here. Create shader, universal render pipeline, and we're gonna do an unlit shader this time. Unlit. We'll call it lava. Go in. Expand. Okay. All right. So you might notice that this shader is slightly different. First of all, it's unlit, so shadows won't affect it. And that's why there are a lot fewer output values here. Now it's just the base color. Now it's just the base color. And that's the output that we're going to be going to. Next, let's add a couple of different variables. We're going to do a texture 2D for fractal noise. We're also going to do one for texture 2 cell noise. We're going to do a texture 2 for side mask. We're also going to do one for round mask. And I believe that's all. Let me check real quick. Shape mask, side gradient. Oh, we also need one for the top gradient. So texture top mask. Okay. We have all of those. Those are all of our assets that we're going to be putting in. Let's also add, we also need to add a couple of more variables. We're going to do scroll speed as a float, or actually, no, sorry, as a vector 2. Scroll speed. Delete this one. Scroll speed, and I think that's all. I'm pretty sure that's all. Okay. Man, give me like 1 second. I really need to bring up my reference material for this. I should have had this up before. Okay. Okay. All right. Last thing, last variable. One more float. One float, and we'll call this whole strength. Okay. And now we're going to set the default values for these things. We're going to set this scroll speed to like 0.1 or negative 0.1. We're going to set this whole strength to maybe, I forget what this should be. Let's do 1 for now. And for these textures, we're going to set defaults to as well. We're going to do fractal noise for that one. We're going to do cell noise for the cell one. Cells. We're going to do the side gradient for the side mask. We're going to do the shape mask for the round mask, and the gradient. Yeah, it's just called gradient. We're gonna do the gradient for the top mask. And now, basically, we're going to start. We're gonna start putting this together. So let's do that. We drag in our fractal noise, we sample it, and we see there. Cool. And we're going to make this start scrolling. So we're going to put in a tiling and offset node and plug it into here, right? And then our offset node, we're going to plug into, actually, no, let's just press space and do time. Then after this, we're gonna do multiply it by our scroll speed. Oh, sorry, no. We're just gonna drag in scroll speed. Plug it into here. And then we're gonna plug that into our offset. So now you'll see in this preview, we're actually scrolling through our texture now. Oh, I guess I was wrong on the negative here. It can be positive. All right. So now it's starting to slowly scroll, almost like lava. Wow, look at that. What we're gonna do after this is we're actually gonna start following the step from that Reddit post that I showed earlier. I'm gonna go back to it just as a refresher. Scrolling fractal noise, and then we add on holes to it. We also only make the top part fully visible. They do some cool stuff. They add a side gradient, they add a shape gradient. We're not doing that, we just have a model. Then they posterize, and then they add the effects. So basically, we're just going through these steps. So we have this, and then we're going to multiply it by a different texture. We want to multiply it with our cell noise sample texture. Then multiply this. The thing is, our cell texture isn't moving, right? We want another tiling and offset. So we're just going to copy this entire thing and plug it into the UV of this cell. And that doesn't look very good, right? So we're actually going to tile these differently. We're going to zoom in. I believe it's 0.2 or something. Do 0.2, 0.5. I actually need to check this. Okay. It's 0.4 for the fractal noise. 0.4. And for the cells, it should be 0.2, 0.5, right? Okay, cool. Perfect. Okay. Oh, before we plug in this into here, we're also going to multiply it by whole strength. Put that into here. Let's make hole strength have a higher default value. Yeah, so it shows up more. Okay, cool. Cool. So now that we have this hole texture, let's add our masks to it. So we're going to multiply it again, or actually we're going to add to it now. And we're going to sample our top mask. Sample. We'll put it into here. Okay, cool. Right. And we're also going to add our side mask to it. Sample. Add. And finally, we're going to subtract our round mask from it. Or sorry, wait, is that right? Round mask. Subtract. Yeah. Wait, what? It's not doing the right thing. Subtract. Default tangent. Round mask. What? Honestly, I'm just gonna multiply this by 2. Multiply this by 2. And then subtract from it. Okay, that's looking better. Maybe we'll even do like 3. Okay, cool. Now that we have that, we're going to put that into a smooth step. The way smooth step works is that it takes in 0 to 1 values, and based on the parameters you give it, if it's within the range, it then like stretches them out. Or it then stretches them out into 0 to 1. If it's below the range, it makes it 0. And if it's above the range, it makes it 1. You know what? I might actually have to do like 1.4 here. Okay. That looks good. Yeah, that looks good. Cool. And after that, we're going to put it into a posterize node. What the posterize node does is that it splits up values into 4 distinct bins. So you can see there's so much gradient here, right? But once I posterize it, it makes it into only 4. And you can kind of see there aren't many holes here. I kind of want to increase that. Maybe I'll lower this value. 0.2 maybe. Okay, good enough. And now that you see that posterization, it sort of looks familiar, right? It sort of looks like the lava. But now we need to colorize it. So we're going to add a gradient in our variables. We're going to call it lava color. and we're going to set the default. So I already have a gradient saved. You can put in these values if you want, or like approximate them. Red at the end, another more orange at 6.5, and then you end with yellow at the end. It's honestly not too important that you get this exactly. You'll still be able to see the application. So we're going to drag in our gradient. We're going to do sample gradient. We're going to put in our posterize. And whoa, look at that. It has color now. We're going to finally plug that into our base color. And check that out. Wow. You can also put that onto our default mesh. It's weird. Dang it. It's annoying. This editor is not very good at looking at stuff. But look at that. Wow. Doesn't that look lava, generally lava-like? Okay, so you might notice a couple of things. This is not double-sided. Let's turn that on. We go to graph settings, and you can hit two-sided. So now it's on both sides. But we also want it to be transparent and alpha clipped. The reason for that is because this is completely solid right now, right? We don't really want that. We want it to be able to cut off. So what we're going to do is we're going to have an alpha clip threshold. And that means if it's below a certain alpha, it just won't show anything at all. So we're going to take in this posterization and drag it into our alpha. And then we're going to make our alpha clip threshold much lower. So 0.001 or something. Wait, you know what? I think maybe we're not using the posterized one. Maybe we're using the smooth step one. Yeah, okay. Yeah. All right. That sort of looks like lava, doesn't it? Cool. Save asset. We can actually put it into our scene now. Drag in lava flow, make a material out of it. Put that on here. And wow, amazing. Oh, you know what? It looks kind of desaturated. I think I don't, wait. Let me check something. I think maybe I wasn't supposed to put this on transparent. No? Maybe, huh. I am confused. Maybe I'm not supposed to put it into alpha. Looks normal here, actually. Wait, yeah, why does it look so normal here?
What's the camera effect?
Possibly? I don't know. I have no idea. Oh, wait. Maybe it's because I didn't save the asset. Okay, cool. Nice. Now it looks like that. So bright, so vibrant. Amazing. And cool. Yeah, you can actually see once you click on this one, you can change some of these. You can make it scroll faster if you wanted. Whoa, so runny. You can make the hole strength larger, so that means the holes are going to be more prominent, or yeah, more or less prominent. If you go back into the shader, we can actually make lava color exposed. Wait, can we not? I don't know why we can't make it exposed. But we can change it in here if we wanted. We can make this lava into, wow, relaxing water. Why is it transparent again? What the heck? I'm confused, but basically, yeah, that's how you do it. Cool, cool, cool. Are there any questions?
Question about some of the nodes.
Okay,
So like,
questions about nodes.
yeah. So like to conceptualize what's kind of happening.
Yeah.
Like the cells, the gradients and stuff, those are just like textures you can make in Photoshop. It's like a 3D image, right?
Yes. So what you would actually generally do, what I did was get images, but that's kind of to mimic a different effect. Usually what you would do is have a node that generates this noise by itself, right? Because this is fractal noise, but that node isn't available on Unity. So I just like got a picture of it.
Okay.
Yeah.
That's what the point of like the sample picture nodes is. Right?
Yes.
Like turning just a regular 2D image into numbers.
Yes.
And it's based on, like you said, like black is 0 and then white is 1.
Yes, black is 0, white is 1. Yeah.
Like those the things we do for the scrolling, we're just moving the position of the points of the picture.
Yes. Yeah.
Okay. That's how we can multiply quote unquote images. It's not really
Yeah, yeah. We're multiplying images together. But technically it's multiplying each individual pixel to the next one.
Okay.
Yeah.
That makes sense.
It's like matrix multiplication, technically. I just realized I didn't actually explain why we're doing each of these masks. This general one is just for the basic like curviness of it. These cells are for the holes, so it kind of like splits up like this. This mask up here is so that the top of it is more defined, because like at the top of the flow you want it to be stronger, and it kind of like determines the shape of it. These side ones are so that these side lava streams are stronger than anything else, and they show up. This shape mask is so that it kind of gets this nicer curve up here and at the bottom. And we smooth step, we pasteurize, we make the color. Oh, and also another thing, if you don't understand why or how it's transparent, it's because black is 0, right? It's being set, the alpha for those areas are being set to 0. And this alpha cap threshold is saying anything below a certain value, we just make invisible. So that's why this works. Okay, I am glad that I got through that in time. This was a shader that I made quite a while ago. And I made it just by looking at that GIF and sort of like thinking about how I could do each step, seeing what the Unity equivalent was, and just like jamming it together in a hacky way in Unity. But that brings me to my other point of if you want to learn shaders, one of the best ways you can do it is just by seeing an effect you like in a game. Knowing that it's from a shader is obviously like experience, but you see it and you should look up a tutorial on something that looks similar, and just go through it step by step, and you'll understand bit by bit what the numbers mean. How do you sort of layer nodes on top of each other to get to the effect that you want to achieve? What are some useful nodes that you can use? That's the kind of thing that you'll learn, and that's what's useful. Okay, that brings us to the end of the workshop. Thank you everybody for coming. And I'll be posting materials. All right, I'm gonna end the workshop now. Bye.